So let's go ahead. Let's look at this. So I hit record. I'm going to full screen. Oh, before I forget, Chapter 6 homework is available to do. It's not due until May 10th. So you got like 3 weeks to get it done. All right. So make sure that you're looking at that. There were a couple people that messaged me on WebAssign, and I'll get back to you today, most likely tomorrow, though. Tomorrow I'll have more time to do it. So I'll get back to you. Don't worry. I did see that you messaged me, but give me a day to write up some solutions for you. So let's see here. Opposites and absolute values. So real quick, we need to define, just like we always do in every chapter, all right? We're going to define some words here. So the first one, just positive numbers, all right? And this is like very simple stuff. I'm pretty sure you know this already. So positive numbers are numbers greater than 0. All right? Now, this is the first time that we're actually going to be looking at this. All semester we haven't done this. Now we're going to start looking at these types of numbers. They're called negative numbers. Now, negative numbers are numbers less than 0. Okay? So, real quick, very simple little diagram. If I were to draw a number line and put 0 right in the middle, any number to the right is going to be positive. And any number to the left obviously will be negative. Okay? 0 does not have a sign. So 0 is just 0. It's neither positive nor negative. All right? So there are ways that we can go about adding and subtracting signed numbers. Okay? The easiest way to do this is just to use a number line. Now, the number line is really effective when the numbers are small. However, when the numbers get large, the number line kind of is tough, but it's really good to kind of visualize it. So I will draw little number lines to visualize, but I'm going to end up giving you an actual rule or a definition for us to use. Okay? So the first thing we're going to do here is we're just going to subtract 3 minus 5. Okay? Now, like I said, this is going to be very simple. You probably already know the answer, and that's great. But I'm going to show you why or how we actually arrive at that solution. Oh, got to go in order. All right, so if I look at the example 3 minus 5, okay? What I'm going to do first, I'm going to do this left to right. I'm going to start at the number 3. That minus sign in between the 3 and the 5, all that really means is that I'm going to move to the left direction, okay? So anytime you see a minus, you're thinking left direction. Anytime you see a plus, you're thinking right direction. So if I want to go in the left direction 5 units, 3 minus 5 is 1, 2, 3, 4, 5, which equals -2. Okay? Are there any questions there? Like I said, it's pretty straightforward. Okay? We'll do one more like this because, like I said, it's very straightforward. I don't want to use... We'll do 8. So -5 plus 8. Okay, so in this example, I'm going to go left to right. So I start at -5. And the plus sign tells me I'm going to move to the right 8 total units. So 1, 2, 3, 4, 5, 6, 7, 8. And I stop at +3. All right, are there any questions with that? That's pretty, like I said, that's pretty straightforward. It's pretty easy. Okay? Later on, we're going to actually develop a rule for this. So, one thing, hopefully, that we noticed. Let me write this out. Positive and negative numbers are opposites of each other. All right, and that's another definition right here. So one thing that we notice, positive and negative numbers are definitely going to be opposites of each other. All right, so if I gave you an example, find the opposite of 5, then you would say, well, since 5 is positive, the opposite of 5 would be -5. Okay? Another example. Find the opposite of -7. So what is the opposite of -7? Can somebody tell me?
+7.
Perfect. And actually, Alex, that kind of leads us into this idea right here. All right, that leads us into this idea right here. If I started at -7 and I asked for the opposite of -7, what I'm really asking for is this. So here's my first number, -7. And if I put another negative out front, that tells me I want the opposite of -7, which is all the way over here at +7. So that kind of gives us a basic understanding of why, and maybe we've seen this before. How many of us have ever heard of this before? And please, like, let me know. I don't know. Raise your hand or put like an emoji or something like that. You know, because I do know how do you put emojis on your screen? Like sometimes people will give me an emoji and I see it on the screen. How do I do that?
You mean like that?
Yeah. How'd you do that?
There's like a little emoji button like on the bottom corner.
Where?
Bottom right corner.
Bottom.
Interactions.
Here's what I see. That's what I'm seeing.
It's the smiley face with the plus sign.
Smiley face with a plus sign. Where do you see it? A smiley
The
face.
positive or plus as a smiley face right next to record.
Right next to record. Oh. Let me go back here. Let me look at this. Because you are sharing your screen. Stop video. Participants. Polls. New share. Pause share. Annotate. No
Reactions.
remote control. I don't think I have reactions here.
Oh my god.
I'm really jealous because I wanted to give you guys. All right. Well, anyways, let's get back to what I was going to ask. Yeah, that's upsetting. I can't do an emoji now. Oh, well. So how many of us have seen this notation before right here that I'm putting a big square around? A negative and a negative make it a what?
I have.
Yeah, it makes it a positive. So now you have an understanding of why it makes it a positive. Is because what I'm really asking is, I'm giving you -7, and then by asking you what's the opposite, I'm putting another negative in front, and the opposite of a -7 is +7. Okay? Are there any questions with that? Yes or no? All right, good. So that leads us into this last thing right here. Okay? How many of us have ever heard of the absolute value before? If you have, just tell me what do you think it is.
The absolute value is the positive number, even if it's a negative plus a negative.
All right, so you're saying like this, right? So absolute value of 5 equals 5. But you're also telling me that the absolute value of -5 is also 5, correct? Is that what you're saying?
Yes.
I agree with you. But can you explain why?
It's the value of the number.
Yeah.
What do you mean by that?
You cannot have a negative number. It has to be greater than 0.
But why?
Those the mathematicians back in the day want to make our lives horrible.
Every value is like the same value.
Every value is the same value. Kylie, I
know what I'm saying. I just can't find the words to explain this.
Yeah, I can't buy that. I'm sorry. I can't buy that.
It was taught to me way a long time ago in like 6th grade, and then I was like, I don't remember.
All right, so let me explain why, because I think it's really good that we go over this. All right, because eventually you start to solve absolute value equations, and you have to understand why there's actually 2 answers to them. Okay, so here's why the absolute value solutions are always positive. Okay, if I look at the absolute value of 5, what I am really asking you is, if you started at 0 and you moved to the right all the way up to number 5, you walked a total distance of 5 units. Okay? Now hold on, Kylie, because I don't like the word value. I don't like. This is the word that I want to hear is distance. Because even if I walked in the negative direction, all right, which would be the absolute value of -5, I still walked a total distance of 5 units. I just walked in the opposite direction. Does that make sense?
Yeah.
So the absolute value is always a positive number because it is a measurement of the distance away from 0. Okay? And that's why it's positive. I mean, think about your car. When you get in your car, if you drive from your house to Target, maybe it's 5 miles. So your speed or your odometer goes up 5 miles. Well, if you went from Target back to your house in reverse, will your odometer go backwards?
No.
No, it keeps counting up. That's because the odometer measures distance, just like the absolute value does. Okay? The only thing we need to be concerned with is when we start mixing up absolute values with parentheses, because sometimes that can get a little confusing. So here are some examples of just simplifying. That's it. So we're going to simplify the following. And we got to be careful, that's all. So the first example, we'll keep it simple. I'm using the number 5 a lot today. Let's use 11. So with this example, we see 2 negatives back to back. So we know that's going to be a positive value. Because remember, the opposite of -11 is +11. Okay? The thing that we have to be concerned with is a problem like this. Okay? Now this one, although it looks similar to part A, or example A, It is entirely different. Because the solution for this is actually -2. Now let me explain why. First, I'm just going to rewrite the problem. The first thing that you're going to simplify is inside the absolute value. This negative out front that I'm going to highlight here, that negative out front is not included with the absolute value, so it stays there. In fact, if you wanted to, you could think of this as -1 times the absolute value of -2. And if you think about it that way, which is the proper way to do this, then you'll see that this is going to be -1 times +2. Because remember, the absolute value of -2 is a distance away. So it's going to be -1 times 2, which equals -2. Does that make sense, everyone? That's like the only, I got to be honest with you, that is the trickiest of the tricky right there. Because you want to see, or you want to go with your gut instinct and say, okay, well, you have two negatives back to back. But that's not the case here. You got to do the absolute value first, and then you worry about the negative on the outside. Part A, you have parentheses and two negatives back to back. Okay? Does that make sense, everyone? Yes or no, maybe so. All right. So now we get into the good stuff. 8.2. 8.1 is really easy. 8.2 is just adding and subtracting. Okay? And we're going to learn some rules here. So adding. Man, my keyboard. All right, so earlier we saw pretty easy examples. All right, I think the one we did, and I'll just do a different one here. Let's say -5 plus 3. So the method that we used was just using a number line. We would start on the left, put a little dot at -5, and then we would move to the right because it's a positive or a plus. So we'd move to the right 3 units. So 1, 2, 3. So -5 plus 3 is -2. Okay? What we're going to do is we're going to learn a rule. And this rule takes the number line and kind of simplifies it a little bit. It allows us to do this with larger numbers. So here's rule number 1. Now remember, this is for signed numbers, so positive or negative. So when the signs of the numbers, doesn't matter how many you have, just look at the sign in front. When the signs of the numbers are the same, add the numbers and keep the sign. Okay? So when the signs of the numbers are the same, excuse me, you're going to add the numbers, keep the sign. All right? So what this allows us to do now is it allows us to look at examples like this. Now this one is going to be really easy. $314 plus 123. Okay? Now, if I were to do this problem, I would just go back to the basics, align them up based on place values, and just add straight down. 4 and 3 is 7, 1 and 2 is 3, 3 and 4 is, 3 plus 1 is 4. And since the 314 is positive, and the 123 is positive, I know my answer is going to be positive. Okay? If you think about this in terms of a number line, all right, if you think about this in terms of a number line here, and you don't have to draw the number line, just watch. If we start off at 314, and then we got to move to the right because we're adding 123, notice that we're just getting another positive number. Does that make sense? Okay? The same can be said about an example like this. Negative 592 minus 191. Now, this right here is a really good example of the rule that we just wrote down, which is if the signs of the numbers are the same. So what you're going to want to do is you're going to look at the number, or you're going to look at the signs directly in front of the numbers. The 592 is negative, the 191 is negative. So what I'm going to do is I'm going to add these two numbers together. So off to the right, I line them like I normally would, and I'm going to add them together. So 2 and 1 is 3, 9 and 9 is 18, carry the 1. 1 plus 5 is 6, plus 1 more is 7. So numerically, I know it's 783. But then I have to look at the second half of the rule, and the second half says, keep the sign. So since both of my numbers were negative from the start, my result is going to be negative as well. So negative 592 minus 191 equals negative 783. Does that make sense, everyone? Are we all on the same page? Okay? Now, if you think about this in terms of a number line, once again, just watch this. I know negative 592 is to the left of 0. And that negative or that minus sign in front of the 191 is telling me move to the left 191 units. So once again, you can see that I'm just staying more negative. Does that make sense? Okay? So now what I'm going to do is just give you a couple of examples. That's it. All right? So here's some examples. How about negative 63 minus 44 and negative 4/5 minus 2/3. All right, what do we get for the first one? First one's kind of simple. Anybody? Negative 107. Perfect. So real quick, we'll just go over this real fast, all right? The signs are the same. So you're going to add the numbers together. And since 63 and 44 were both negative, my answer will be negative as well. Okay? Now, The next one, it doesn't matter if you have fractions. What we're really learning about here are the signs. So the 4/5 is negative. The 2/3 is also negative. There are minus signs in between them. So what I'm going to do is add the two numbers together. All right. Now I know for us, we got to add fractions, which means we need a common denominator. So let's build some equivalent fractions real quick. Now, hopefully you remember how to do this. To find the LCD, you just write the prime factorizations of 5 and 3, and then you multiply them. Well, they're both prime, so 5 times 3 is 15. This I'm going to multiply by 3 over 3. That gives me 12 over 15. The second fraction I'm going to multiply by 5 over 5, and that gives me 10. So this is 12 over 15 plus 10 over 15, which is 22 over 15. All right. However, since 4/5 and 2/3 were both negative, my result is going to be negative as well. Does that make sense so far, everybody? Yes or no?
Yes.
All right, perfect. Good. Now, here's the second rule. In this second rule, we're going to have to take just a little bit of time with it, all right? Because it can get confusing, but once you see how it works, all right, and you can visualize it a little bit, it's very simple, okay? All right, so here's our second rule. I'm going to write it and then I'll say it, okay? All right, so here we go. Rule 2 is a lot more involved, but hopefully it's not as bad as what you would think. So rule 2 says, if the signs of the numbers are opposite, okay? And your book just gives you like a big long sentence. I broke it down into 3 little parts because I think it's easier to break things down. So the first thing you're going to want to do is just find the absolute value of each number, and I want you to label the larger absolute value. So whatever number turned out to be larger after you took the absolute value, label that larger. Then, step 2, you're going to subtract the smaller number from the larger number. So all I did is I just wrote larger up top minus smaller, and you're going to get a result. And then step 3 is where you determine what the sign is. The answer will have the same sign as the larger value from step 1. Okay? All right, so, I'll wait a second here so you can write this down. And then we're just going to do a bunch of examples, okay? All right, are we good? So let's look at this simple example, negative 59 plus 13. Okay? Now, here, let's start over. We're going to look at the signs in front of the numbers. They're opposites. One's positive, one is negative. So I'm going to break this down so you can see every little step. So here's step one. We're going to take the absolute value of each number. Now, after we take the absolute value, we're going to label which one's larger. In this case, the 59 is larger. All right, now here's step two. Step two, I'm going to take 59 minus 13. Okay, 59 minus 13. And we just subtract. 9 minus 3 is 6. 5 minus 1 is 4. And then here's our third step. We're going to use the sign of the larger absolute. So in this case, since the 59 was considered the larger absolute and it's negative, my answer is going to be negative as well. So negative 59 plus 13 equals negative 46. Okay? Now, you don't have to write this down because it's going to be tedious. But I'm going to write it down just so you can see it, okay? Should I give myself a little bit more space here? All right. So like I said, and hopefully now you can see the downfall of the number line. Number one, my number line is garbage. It looks horrible, but that's okay because I'm just trying to illustrate a point. If we're starting off at negative 59, this plus sign tells me I'm moving in the opposite direction of the negative, which means I'm moving to the right. And I'm going to move to the right 13 units. Okay? So the thing is, I don't move enough to the right to get out of the negative side of this number line. And that's why my answer is just negative 46. So if I were to just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Notice that I ended up on negative 46 anyways. So you got two rules that you got to know. The first rule, if the signs of the numbers are the same, then you combine the numbers and keep the sign. So you just add them and keep the sign. If the signs of the numbers are opposite, then you just follow those three little steps. Step one is to create the absolute value of each, label the larger. Step two is to subtract larger number minus smaller number. And then step three is just to figure out what the sign is. All right, let's try another one here. So we're going to try 164 minus 591. So I'm going to let you do this one. All right. Did anybody get an answer yet?
I got negative 427.
Anybody else get negative 427? Jameson, is that what you got?
Yes.
Oh,
You got the same thing.
all right. Well, let's go through it real quick. So step 1, let's find the absolute values. So this is definitely larger. Step 2, we're going to take 591 because that's the larger. We're going to subtract 164. So I have to borrow, which stinks. Oh, nope, that stays a 5. So 11 minus 4 is 7. 8 minus 6 is 2. 5 minus 1 is 4. And then step 3 is the easiest step. Negative 427. So good job. Now, there is one situation that we need to be aware of. Okay? And that situation is in this example right here. All right, that situation's right here. This is the one that we need to be a little bit careful about. Okay, because we've already seen this. We know that if you have two negatives back to back and there's parentheses involved, then those two negatives turn into a what?
Positive.
Good, good. So the first thing we need to do here, before we do anything, is rewrite the problem as 4,322 plus 395. Okay? So now you can see both of these numbers are positive. So that's going to be rule number 1. So I just stack them on top of each other. And just add. 2 and 5 is 7. 2 and 9 is 11. Carry the 1. That's going to be 7, 4. So 4,322 minus a negative 395 is 4,717. All right? So if you think about this, what this is really saying is take negative 395, find the opposite of that, and go in the opposite direction. So you're actually adding 395 to this. All right? Now, if we need to be careful of this situation, then we also have to be aware of this situation. Actually, let me do this too. There we go. So now we need to be careful of this situation as well, where you have negative 158 minus the absolute value of negative 213. Are these two problems on the board right now, are they the same? Are they the same type of problem?
Yes.
Be careful, B.
No.
No, I'm going to use a different rule for this second one. Because remember, when you see the absolute value, even if you have two negatives back to back like we do here, let me point them out what I'm talking about. Even though we see those two negatives back to back, because this is the absolute value, I have to do this first. And we know that the absolute value of negative 213 is positive 213. In fact, I might be moving too fast here. Let me just do this. So the absolute value of negative 213 is positive 213. So now when I go to rewrite, I have 158. I still have that minus sign in front of the absolute, so that minus sign is still there. But now I just write 213 because it was positive. And hopefully here you can see that these signs are opposite. So I find the absolute value of 158, the absolute value of 213, negative 213. All right, because remember, we look at the sign in front. So that was step 1. label it. Step 2, we're going to subtract 213 minus 158. So I have to borrow that. This turns into a 13. This turns into a 0. 13 minus 8 is 5. Now I have a 0, which means I need to borrow again. So 10 minus 5 is 5, and 1 minus 1 is 0. So 55 is the numerical answer. And since the 213 was larger, my result is negative 55. So 158 minus 213 is negative 55. Does that make sense, everyone? Okay? Now, here's a question for you. Where do we see signed numbers? You probably looked at them today. Where would we see positive and negative numbers around us?
On a thermometer.
Thermometer, excellent. So, signed numbers exist everywhere. Some examples. Thermometer. Anywhere else? How about elevations? We know, and here's my artistic ability. We know we can have mountains, you have fish living in the water, and where the water meets the bottom of the mountain, that's called sea level. Well, that is 0 feet. Anything above sea level is considered positive, and anything below sea level is considered negative. All right? So, thermometer, elevations, anywhere else? I can think of one. It's very important to me. I don't know about you, but it's really important to me.
In the fridge.
We're out in the fridge.
I don't know, like the freezer and the fridge. The freezer's usually.
Perfect, yeah. No, that goes back to thermometer. You're good, you're good. I keep my fridge at negative 4 degrees. The reason why I know that is because I have a button I hit. And I just made it as cold as possible. Where else? How about your bank account? Hey, B, do we want positive numbers or negative numbers in our bank account?
Positive, obvious.
Why positive?
Because it just, I don't know, it makes me happy to see positive amount in my account.
I have never agreed with you more than right now. I agree 100%. If you start seeing negative balances, that means you owe money. You don't want to owe money. I don't want to owe money. Owing money's the worst.
Yes.
So you definitely want to see positive numbers in your bank account. So signed numbers exist everywhere. But what's really interesting is they weren't always there. Somebody had to invent them. Somebody had to create them. I don't know when they were created. I can look that up. But I think it was around the time that people started to borrow things off of other people. And they wanted a record of that. A long time ago, when banking systems were created and stuff like that, it's really cool. Nowadays, do I have one in front?
There was a, like, they call call it barter system? I don't know. Barter system or something.
Yeah, well, bartering means that you have a talent, I have a talent. So you'll do something for me using your talent, and I'll do something for you using my talent. So like if you were a plumber and I were a construction worker, I would come to you and say, "Hey B, I noticed that you wanted a second bathroom on your house. So why don't I build it for you? But then you can take your plumbing skills and come over to my house and fix my toilet or something." That's bartering, okay? I don't have one in front of me, but nowadays when you get a loan or a mortgage or something like that, you get like a little book, and it has all these little payment cards in them. And every time you send in your payment, you're supposed to tear off a little piece and you include it in with your payment. Well, a long time ago, they didn't have that. What they would do is they would hire artists, and an artist would draw a very special picture that represented the amount of money that you borrowed. And once they were done drawing the picture, they put it on the edge of a desk and they broke it in half. And the bank kept one half and you kept the other half. And every time you came in to make a payment, they would line up your picture, and then the artist would draw something else in there and then hand it back to you, and the bank would hand it back. And you would keep doing that until you paid off your loan. So I think that's when signed numbers really started to take off. All right, so there's a little math history for you. I don't think anybody knew that before. Did you? Matt, did you know about that? Excellent, you didn't. So let's just look at one or two word problems. All right, and this is in the news right now, so it definitely interests me. So Rover is one of the it's one of the machines on Mars that is currently roaming around. There's a couple of them on Mars. We just landed another one. I forget the name of that one though. All right. So Rover records high and low temperatures of negative 24 degrees Celsius and negative 109 degrees Celsius for one day on the surface of Mars. What is the change in temperature for that day? Okay? What is the change in temperature for that day? So here's what we know. We know that on one specific day, the temperature probably started at negative 24, and then it went to negative 109. What I want to know is, what is the change in temperature for that day? How many degrees separate those two temperatures? That's what we mean by change in temperature. So, excuse me, so how would I do that problem?
You can do 109 minus 24.
So you want me to write it like this, 109 minus 24? Is that what you're saying, Jameson?
Yes, that's how. That would show you the difference in temperature.
Okay, but here's what I want to know. And this is the question. What happened to that negative sign? Because when you told me to write it, it just disappeared.
I don't know. I mean, I still put negative, like, because the change is 85. So I don't know how to do that without having, like, the negative.
All right.
9.
So I'm going to show you, okay? So a change in temperature, and this goes, anytime you see the word change, all right, this is what you can think. In this case, it's specific change in temperature. It's temperature 1 minus temperature 2. Okay? So for us, we know this change in temperature goes from negative 24 to negative 109. Okay? So what I can do is I can write negative 109 minus negative 24. Okay? Now to help us with this, we have two negatives back to back. So that means it's going to change to a positive. All right, and we get negative 85. So I know the distance between, now think about what I just said there, because I'm going to come back to that. The distance between negative 24 and negative 109 is 85 degrees. And since I'm saying the distance, the change, I hope everybody's looking up at the screen right now. I could put absolute values around everything. And that's how, Jameson, you got the 85 degrees Celsius. So that was the change. Okay? Does that make sense, everybody? Pretty straightforward?
Yes.
It's all about how you read it. All right? And you gotta understand how to interpret this. Now, here's another one that's kind of a little tricky. All right? Same setup, okay? On day 2, I don't want to do day 2 because for my mind, it doesn't make sense. So how about day 286? So on day 286, the morning temperature, I'm gonna be specific. Morning temperature was negative 5 degrees Celsius. And the afternoon temperature was 15 degrees Celsius. What is the difference in temperatures? Okay? All right, so with this one, all right, I want the difference in temperature. So I want the final temperature, which is 15, and the difference means subtraction. And I'm going to have to subtract negative 5. And by doing that, this actually changes to 15 plus 5, which is a 20 degrees Celsius temperature difference. And hopefully that makes sense, because if you were to look at a number line, all right, you know the distance from negative 5 to 0 is 5 units, and the distance from 0 to 15 is 15 units. So the total distance is 20 units. In this case, the units are degrees Celsius. Does that make sense? So there are a lot of things preventing us from hanging out on Mars for a while. Temperature is one of them. Keeping a human in space is another. All right?